Good morning. Today we will see the last assignment of NPTEL, that is NPTEL assignment 12. In this we have 9 questions, so we will go one by one. So in the design of bolted gusseted base, what is the minimum thickness of the gusset plate that can be taken? So that is given in their materials. Steps for the design of gusseted base. The gusset plate should not be less than 60 in thickness for bolted gusset base. And same that was as minimum thickness of gusset plate for gusseted base. So we have that option is C 16 Then a column series of factorial compressive load. 1400 kilonewton, calculate the area of the slab base required in the design of gusseted base. And this is given M25. So we have given area that is required P upon 0.45 FCK. So A equal to PU upon 0.45 FCK. So we have given factorial load, so 1400 into 10 raised to 3. And we have this value that is 0.45 into 25, and that comes 11.25. And from this we will get area 144.44 into 10 raised to 2 square. They have given in centimeter, so we have this as 1244.44 centimeter square. So option we have, option is option D. So now we have third, in case of column connected to base plate through gusset plate, the loads are transferred from column to base plate. So here they have mentioned gusset, the load is transferred. This is gusseted base, and question we have that is also in a column connected to base plate through gusset plate. So that is gusseted base. Partially through bearing and partially through gusset plate. So partially through bearing and partially through gusset plate. Option is C. Then slab base are mostly suitable and economical for. So that is load, axial load on column. So these are not for heavy axial load. For heavy axial load, we are using gusseted base. Then we have fifth, a column carries a factorial compressive load of 1200 kilonewton and factorial bending moment of 70 kilonewton meter. If a base plate with the length 400 and width of 500 is provided, then the maximum and minimum pressure experienced by the plate will be. Now, if you remember, in case of column that is in eccentric column, we have values, if you remember, we have sigma max, sigma mean, and that is equal to P by A plus minus M by I into Y. And that we have P by A plus minus M by Z, because we have Z equal to I by Y. And from this, we will get value of sigma max and sigma mean. So now in this, we have first P by A, that is Pu upon A, 1200 into 10 raised to 3. Axial load is given, divided by 400 into 500. So 6 Newton per mm square. Then find value of mu by Z. So mu we have given 70 into 10 raised to 6. And then we have BD square. So we have minimum B 400 and D 500. So BD square by 6. It comes 4.2. And now according to this, we have plus minus this value. So if we will put it, then we have Pu by Z plus mu by Z. 6 plus 4.2, that is 10.2 Newton per mm square. And minus, so we have 1.8. And for this, that is we have option, that is option is C. Then we have question number 6. A bolted gusseted base is used to transfer a factorial axial load 1500 kilonewton. D is given, BF is given, and thickness of gusset plate is given. We have to find length, and that is parallel to web of column section. So here clearly mentioned base plate parallel to web, and we have L equal to depth of section because this height your base plate is in this mesh. And then here we have that is gusset plate, then we have gusset angle, and then we have overhang. So if you will draw it in plan, then you are in this mesh. So we have on both sides gusset plate, then we have gusset angle, and then we have overhanging. So same we have on this side. So we have column, then gusset plate, gusset angle, gusset plate, gusset angle, and then we have overhang on this side. And therefore we have this value that all are given 350, that is given D. Then we have given 14 gusset plate. So two times because we have on both sides. Then we have clit angle 75 and overhang we have 70. And from this we will get value of L 648. So we can write it as 650 millimeters. So we have 650 millimeters. Then we have 7, the span of a gantry girder with hand operated. So in hand operated, we have 10% impact. And if it is electrically operated, then it impact will be 25%. So now it is given, so 220 kilonewton, these are given. And we have to put this, if you remember, so we have condition that is CG of wheel load, CG of wheel load, and one of the wheel load, and one of the wheel load should be equidistant from center. Should be equidistant from center. Equidistant from center. And now we have given 2.5. So if I will draw these two here, and we have these two values as 220 kilonewtons. And then we have this as 2.5. My CG will be at center. This distance will be 1.25. And now CG and one of the wheel load. So we have in this mesh. So if I will say I have CG, so here, center. So I have this will be given 8 meter. So this will be 4 meter. And this will be 4 meter. So one of the wheel load means I will get this distance, and that I will get it as 0.625 because half of this. So we have this will be 0.625. 0.625. So this distance becomes 1.875. And then we have distances accordingly. So now if we will find value, so let us we will find this value. This is VB and this will be VA. So now if we will take moment about A equal to 0, then we have 220 into 4 minus 1.875 plus 220 into 4.625 minus VB into 8 equal to 0. And from this we will get value of VB. I will just calculate it. 4 minus 1.875 into 220 plus 220 into 4.625 divided by 8. And value comes 185.63 kilonewton. 185.63 kilonewton. And maximum bending moment is under the wheel load. Maximum bending moment, I will write here. Maximum bending moment under wheel load. And it comes mu max equal to 185.63 into 4 minus 0.625 under this load, which is away from the reaction. And we will get it as 4 minus 0.625. So we will check it 185.63 into 4 minus 0.625. So it comes 626.50. So equal to 626.50 and multiply it by 1.1, it comes 689.13 mu max including impact. Including impact. And that will be equal to 1.1 into 626.5. And we have this value 689.15 kilonewton meter. So they have asked maximum factorial moment. So it should be kilonewton meter. And we have this option will be option A. Then we have this question. Now in this we have to find the thickness of gusset plate. Now you can see we have a ISHB 350 on both sides. So this will be 450. And this will be given BF and 100 on both sides. So this will be 350. So I will mention it outside. So we have this will be 350. And then we have this as 450. And therefore we will get this value PU upon A. So 450 upon 350. So we have this value that is W. Then A we have that is on both sides. A and B we have both 50. So we will put it, and from this 2.5, W is 8.89, A is 50, B is 50, gamma mu 1.1 upon 250, and we will get 13.08 millimeter. And in option we have that is 14 millimeters. So option is B. And then we have last question, find the maximum allowable bearing pressure between the base plate and concrete foundation, and value that is maximum allowable bearing 0.6 into 25, 15 MPa. So we have value that is 15 MPa, option is A. So likewise, we have to solve the questions of assignment 12, and this completes your all assignments of NPTEL. Now we will stop here only. Thank you.